Mr. Minnick here, helping my students with control expressions worksheet number 1. At the top of this worksheet, it all works in such a way that the line of code asparagus equals yes, and the line of code broccoli equals no executed in the Python program. And you're supposed to interpret the rest of the worksheet with those two lines of code having executed, which really means that anywhere that you see asparagus, you could think of that variable as actually being the word yes, and then that would simplify the worksheet, but it would take a lot of time to go through and write the word yes everywhere that you see the variable name asparagus. And while you're at it, you'd have to write the word no in for all the occurrences of broccoli. I don't think you should take the time to do all that, but you could if you really wanted to. Okay, this worksheet is kind of built to match up with my lecture notes that currently in 2017 have a story, an example of how you can build a truth table with the idea of somebody eating asparagus or not eating asparagus and broccoli and then getting dessert or not, with a strict parent and an easy parent. Now that means nothing to you if you're from another country watching this video, but I encourage you to read my lecture notes if you can find them, and this worksheet might make more sense. Let's move on now and do a couple sample problems. So the first exercise is asking, hey, is it true or false that asparagus is currently equal to yes? Well, because of what I just talked about on this whole worksheet, asparagus is equal to yes. So yes, indeed, yes is equal to yes. So that is a true. And I recommend that you put a little T above the equal symbol so that I know as scratch work that you knew what you were doing here and that came out to be a true. But as far as an answer goes, when I grade the worksheet, I need the T to be circled. So there's the answer to number 1, it's true. Let's skip down and do some harder problems, like maybe this exercise number 5 that has the word and in there. So let's calmly work from left to right and follow the order of operations. Well, first, you have to plug in whatever asparagus is equal to, and it's still equal to the word yes. So think of that as the word yes. Whether you write it out like this or not, it's up to you because I don't care about that part. But then you say, hey, what does this mean? Exclamation mark equals. Well, if you look it up in my lecture notes, or you just spend any time learning Python, that symbol is the same as what an algebra student thinks of as the not equal to symbol. Since that's not on a keyboard, computer scientists type this together, an exclamation mark followed by an equal, meaning the same thing, not equal to. You will, in other computer languages, sometimes see it written this way as a less than, greater than. And I've even seen it some other ways that I can't think of right now. But in Python, this right here means not equal to. So let's now interpret and evaluate the whole expression in number 5 to see what the answer is. So we're asking basically, is yes not equal to yes? Oh, that would be a false. Think about it. It's yes not equal to yes. It's like me saying Minnick is not Minnick, but I am Minnick. So it's false to say that I'm not Minnick because I am Minnick. So anyway, that we put a little F there above the not equal to symbol when I like people to do scratch work. And now we're done with this side of the expression, kind of like as if that was in a set of parentheses. Because the not equal to symbols here are higher on the order of operations than the word and, according to, please excuse my dear Aunt Sally, which I'll fill in this chart later, not equal to symbols are done before ands. By the way, I'll just tell you now, the word and is always done before the word or if you see an or in the exercise. Also up here with not equal to, tie is the double equals, which means equals. It's got to be a double equal symbol, by the way. And other ones that are high up on this list are the less than, greater than, less than or equal to, and the greater than or equal to. I think that covers it. So all of these are called relational operators, and they're always tie, and you work from left to right. But they're on a level above and, which is on a level above or. So it's kind of like this is first, this is second, and this or would be third. Now the word not, when you see it eventually, that's above everything. So actually I meant for that to be 1, and this is really, this whole group is 2, this is 3, and this is 4. So we'll come back to this later if we get stuck. But if there are parentheses, you always go by the parentheses first. Now that's like grouping symbol, and I'm not going to add that to my chart. All of this is explained in my notes. Please read my notes. Okay, back to number 5. So we just got a false on this side. But now we have to do this because the not equal to symbol is higher than the and. So I ask, is broccoli not equal to yes? Well, you see broccoli is the word no. And the word no is not equal to yes. That is a true thought. That is true. No is not equal to yes. So we put a little t here, meaning that this whole expression is true. So we're left with now a false anded with a true. If we were doing this as steps in an algebra exercise, I probably would have written this out now as 3 like steps. Instead, I'm just using this red pen and hoping that you understand. So how do you know whether an and works out to be true or false overall, so you know what the final answer is? Well, you look at your truth table, which I don't have as a handy reference on this guide. But let's say that you had to make a truth table real quickly under pressure on a test, or if you were a judge or a lawyer in court, you had to make a little truth table to figure something out. Because sometimes the witness that's on the stand might be confusing in their way they word something, and you have to get them to simplify to whether true or false they were at the scene of the crime. And then you can like help prove your client innocent or not. Well, anyway, here's the truth table. Asparagus, broccoli, and an or are your column headings. You have 4 children in the family. The person who eats nothing, the person who does eat broccoli, the person who eats asparagus but not broccoli, and the person who eats everything. And then the strict parent, when you have the word and, well, if you don't eat anything, you don't get dessert. False. If you only eat one thing or the other, you still, according to strict parent, you don't get your final true, you get a false. And this kid does get dessert. Now, if it's easy parent that's in the house with the word or, then only this first child does not get dessert. All the other kids get dessert because at least they ate something. And by the way, this is the binary numbers 0, 1, 2, and 3. And there's all kinds of other beautiful things about this thing called the truth table. Well, right now, we have to go back to number 5 and realize that F is the same thing as a 0. True is the same thing as a 1. And of course, is this column here. So when you have a 0 anded with a false, when you have a 0 anded with a 1, I meant to say that's a 1. A 0 anded with a 1, that's basically this entry right here in the truth chart. Because a 0 anded with a 1 means that overall you don't get dessert. In other words, the answer to number 5 is false. Okay, in case that was too confusing for you, I'm going to do another careful one to be clear to students that are watching this video still. Let's look at number, number 10, that's a doozy. Let's look at number 10. Now number 10, because according to the directions in the worksheet, asparagus is equal to yes everywhere in the worksheet that you see it, this right here is like a yes. And yes is equal to yes, so quite clearly, this little set of parentheses, which you got to do first according to order of operations, that's like a T. That's a true. That little part is true. But when you have a not in front of a true, and because not is at the very tippy top of the order of operations, you got to do the not because parentheses were actually above that, but the not's next. So a not changes a true to a false. It's like a negative sign in math. If you have a true in the parentheses and you're nodding it from the outside, it just flips this true, and now that true is really a false. So maybe you cross out the T or use your eraser, it's up to you, and put an F there, because now this side of the expression is false. But we did do the not. The not's used up. So maybe you put a line through all of this to show yourself that you've now simplified all that to just a false. We're only halfway done, as you can see, because we still have another side of this expression to do. Please understand that the word or is saved for the very end because it's at the bottom of the order of operations here. So we have to work from inside these parentheses out, and let's look at broccoli. Broccoli, according to this worksheet, is equal to no everywhere that you see it. So I'm just going to be super safe and write the word no above it, then ask myself, is no equal to yes? That is a false statement, because no is not equal to yes. So overall, this is a false. Above that equals. And we've now simplified all this to just a false. But don't stop and don't go too quickly on this worksheet, because this not is hanging out here outside of this set of parentheses, which we didn't take into account yet. We didn't do the not yet. So somebody, here's your chance to be famous on one of my YouTube videos, because I have like 4,000 followers, or 400, something like that, or 40,000. Anyway, Nathaniel, loudly for the camera and the microphone. What's the not of a false simplify to?
True.
Good job. Very confidently. He knows that that whole side is now a true. And we're left with, Lucas, what do you get when you have a false, overall false, ORed with a true?
True.
You got it right here. False, ORed with a true yields this answer right here. Overall, the answer to number 10 is true. On this worksheet, which is not real lifelike down towards the bottom, no coder would ever go and type not. Just like no algebra student or algebra teacher would put like 5 negative signs next to each other and then some number in parentheses. Because they kind of like cancel each other out. And if you have an odd number of nots, then every 2 of them kind of cancel each other out, and you're left with like this 1 knot in number 13. In number 12, the 2 knots cancel each other out, because whether asparagus is equal to yes or not, if you have a true knotted twice, you're back to true again. If you have a false knotted twice, think about it, it's back to false again. So I throw some little tricks in that if you ever take the AP exam in computer science, or you just end up in some weird world of like misfit toys, you see these weird things, like a jack-in-the-box that has like 2 heads that spring out. You normally don't see it in real code, but I throw it on a worksheet. And last of all, the word yes in uppercase. Jack, loudly for the microphone. Is the word yes equal to the word yes? Correct. That was a trick question, and you got it right. So the answer is false. The word yes in uppercase is not the same thing as the word yes in lowercase. In Python's mind, it's case sensitive. So when you're in double quotes like this, unless it's spelled with the right upper or lowercase combination of letters, you can't log in correctly if it were a password and you typed uppercase. So that will help you with number 15. I'm not going to say the final answer, but hopefully you can figure it out. I pretty much helped you. And the last thing I'll say, then I'm going to sign off, number 14 is extra tricky because you have an or, and you have an and you have no parentheses. So I just emphasize that you better follow the order of operations very carefully if you want to get number 14 right. Those last 2 numbers, 14 and 15, I made them tricky. Good luck with that.